for answers. So, but before we continue, what do you want to study when you pass matric?
Engineering, sir.
Which one?
Mechanical.
Mechanical. Okay. Okay, that's good. Yeah, because it needs a lot of maths and physics.
Yes, sir.
All right. The question says, two girls standing at opposite ends of the rope, each makes a pulse at the same speed. Pulse A with an amplitude of 4 centimeters moves to the right, and the pulse B with an amplitude of minus 6 centimeters moves to the left. The pulse meet at point C. Now, state the phenomenon observed when the two pulses meet at C. What is it? What do we call this phenomenon?
I think it's going to be destructive interference.
Oh, yes. But the phenomenon or the umbrella between the two, between the two interference is
Superposition.
yes, superposition. Okay. Let me connect my pen. Superposition. And what will happen there is it's a destructive interference. Okay. 1 point, no, 3.1, 3.1, you said was the phenomenon superposition
Superposition.
or destructive interference. Okay, 3.2. Draw a label diagram to show the resultant pulse when the two pulses meet at C. Label the pulse clearly. What do you think will happen?
I think it's going to be a straight line.
No. Remember, this is 4. And this one is 6. So 6 minus 4 equals 2. I don't know if you agree with me.
Yes, sir.
Yeah, so this will be, no, actually it will be minus 4 plus 6, so it will be minus 2. Minus 2, it means you will have a pulse like this. And the amplitude will be 2 centimeters. Do you agree?
Yes, sir.
All right. 3.3. So the only time when you get a straight line is when the two pulses have the same magnitude. Are we in the same page?
Yes, sir.
All right. Name the type of interference that take place when the pulse meets. Destructive. You've already said it. Destructive interference. Okay. 3.4. Says determine the resultant amplitude at C. We have already determined it It is a -2. We agree.
Yes, sir.
-2 centimeters from -6 plus 4. Okay.
Yes, sir.
3.5. We have, it's not 3.5, it's 3.4 and 3.6. Okay, but it's fine. 3.6. A wave produced by a learner A on the left has a wavelength of 48 centimeters and a period of 0.3. Define a wavelength. What is a wavelength?
Distance between two consecutive points that are in phase.
Correct. Distance between two consecutive points that are in phase. On the wave, okay, sharp. That's 3.6.1, 3.6, 3.6.2. We have calculate the speed of the wave. How do we go about finding the speed of the wave?
It's going to be V is equals to frequency times wavelength.
F lambda. Our frequency is what is our frequency? We have frequency.
No, sir.
Okay. We are only given the period. What is the relationship between period and frequency?
They have the same formula, sir.
Do you agree with this?
Yes, sir.
Do you agree that frequency is also equals to 1/t?
Yes, sir.
So I can come and put 1/t times lambda. 1 over the period was 0.3 times lambda is 48 centimeters. So what do I put? Times what? What is the unit of lambda to start with? Because that's where we must start from. Komisa, what is the unit for the units for wavelength?
I forgot, sir.
Wavelength, first of all, is a length. It is measured in meters. And the period in seconds. Ne? So
Yes,
let's go back to the question and check if they are all given in their respective units. Okay. The first one is in centimeters, which is 0.48 meters. I don't know if you agree.
Yes, sir.
And then your period is already in seconds, so we are okay with it. Is that fine?
Yes, sir.
Okay. So we will have lambda as 0.48. Now, to see how we go to the answer, this is 48 centimeters. We divide by 100. If you divide 48 by 100, it is 0.448. And we just take it and put it there. So if you use your calculator, what is it that you're gonna get? You will get 1.6. What is the units of speed?
It's V, sir.
The units.
Yeah, it's
because V it's volts. Okay.
It's miles per second.
Miles? No, that's an American unit.
Yeah.
We don't measure in miles in South Africa.
Is it meters per second, sir?
Correct. And again, to see, you see that the units of speed is actually meters per second. It also gives you a hint of what your units will be for your wavelength and also your period. In order for us to get to meters per second, there must be a meter somewhere, somehow. There must also be a second. And these two are the units of our ingredients, which is your period and also your lambda. So if you get your lambda in kilometers, you must always convert it to meters. If you get it in millimeters, convert it to meters. The same thing with your period. If you get it in minutes, you must always convert it to seconds. All right.
Yes, sir.
Okay. So I want to look for another question. I'm gonna try to do question papers where I can. Previous question papers. Okay. And as I'm looking for the question papers, I just want to ask you a few questions. What is the formula of forces? What is the formula of the magnitude of force between two charges?
Can you please repeat that, sir?
What is the formula for a force, for a magnitude of a force between two charged objects?
Is it I is equals to Q over change of time?
That is current. That is electricity. You're talking about the electricity chapter. The force between two charged objects. First of all, if it's a force, it must start with F. F equals KQ1, Q2, all divided by R. Oh, actually, you guys don't do that, man. Oh, yeah, no, sorry, I forgot. It's a grade 11 thing. I forgot.
Yeah, also confused for a second.
yeah. Now I'm starting to confuse you. Okay. Oh, now okay. Let me ask you this one. What happens if you put two charges? If you put two charged objects into contact and then you separate them, what happens? Okay. Um, Okay, I'm gonna do a question on electrostatics. Ne?
Yes, sir.
Okay, so I'm gonna clip it quickly. Okay. Yeah, so this is what we have. Okay, two identical metal spheres A and B are placed on an insulated stand. Sphere A carries a charge of 4 + 4.4 nanocoulombs, and sphere B has a charge of plus 1.25 times 10 to the power of 10 excess electrons, not a charge, excess electrons, right?
Yes, sir.
The first question, state the principle of charge quantization. What is charge quantization?
All charges are multiples of the smallest charge.
All charges are multiple or the multiples of
The smallest charge.
the smallest charge. Which is what is the
An
magnitude of
electron is 1,6 times 10 to the power of -9 coulombs.
-9 or -19?
-9, sir.
Okay, go back and review it. Do you have the notes?
Yes, sir.
Okay, check it again.
Oh, yes. 19, sir.
Yes, don't forget it, please. Okay. To the power of -19. What is the units?
Coulombs.
Coulombs, yes. That's the smallest charge. So if I have 3.2 times 10 to the power of -19 uh, charged object, how many charges are there? How many charges are there? You agree you have two charges? Because if you divide 3.2 times 10 to the power of -19 by the unit charge, you will get 2. But we were
Yes,
just
sir.
passing by. Do you agree?
Yes, sir.
Okay. Now the formula says the number of charge is equals to the charge divided by the unit charge. The charge of the object divided by the unit charge, that you will get the number of charges. Right. Calculate the charge on sphere B. What is the charge on sphere B? How do we go about it? Kumisa, do
Can
you
I
have that?
please see? Can I please see sphere B again, sir?
We're gonna have
Please see sphere B.
PC.
May I please see sphere B?
Oh, sorry. Okay. Did you see it?
Yes, sir.
Yeah. So how do we go about it? You have any idea? Do you
No,
agree with
sir.
that? Do you agree with that?
Yes, sir.
We are given the number of charge. Do we have QE? I think we have. QE, or the smallest charge, is how much?
It's 1,6 times 10 to the power of negative 19.
Yes. So we only need Q. So do you agree that we have N, which is 1.25 times 10 to the power of, let me see, the power of 10.
Yes, sir.
It's all equals to Q. This is the charge that we are looking for. Then 1.6 times 10 to the power of minus 19. So how do we solve this equation?
I think we're going to use the Q nu is equals to Q1 plus 2Q divided by 2 formula.
Or to calculate a QB?
Yes, sir.
No, not at all. The thing is, they are trying to trick you. They have given you the number of electrons, not the charge. So they want you to use the principle of charge quantization to see how the amount of charge that you're gonna have if you have 1.25 times 10 to the power of 10 number of electrons. They want you to use the charge quantization. You were given the number of electrons. So in order for you to find the charge of an object, you have to use this formula. And that's what we have used. We've just used. So QB, if you cross multiply 1 times QB, it will give you QB. Is equals to 1 times 2, 5 times 10 to the power of 10 times 1.6 times 10 to the power of minus 19. This will be, if we use our calculators, we're going to get 1.25 times 10 to the power of 10 times 1.6 times 10 to the power of minus 19. So it is going to be, you see, a 2, 4, 2, 4, 6, 8, 9. This will be, I think it will be 2 times 10 to the power of minus 9 coulombs. Did you get that answer?
Yes, sir.
So that is the charge of B. They were just tricking you by giving you the number of electrons, so that you can find your total amount of charge. How do you find the total number of charge? You use the formula N equals Q divided by QE. Did you understand that one?
Yes, sir.
Okay. Write down the name of the type of field around the charge sphere. Choose from magnetic, electric, or gravitational. There's field around the charged sphere. Is it magnetic, electric, or gravitational? What do you think?
I think it's going to be magnetic.
Why magnetic? It is not a magnetic field, because a magnetic field consists of north pole and the south pole of the magnets. There must be magnets. Do we have magnets or we have charged objects?
Charged object, sir.
So a charged object is very different from a magnet. But we are using a magnet.
Yes, sir.
Yeah, so this is not a magnet. This is an electric field, because it is a field around a charged object. And remember, we are dealing with electrostatic forces. Within the term electrostatics, there is the electrical part of the term. So it is electric. Okay, give a reason why the charged sphere are placed on insulated stands. Why are they placed on an insulated stand? First of all, how do charges move? Okay, let me ask you, what is a current?
So it's
What is a current?
The flow of charges inside a conductor over a specific time.
What is a conductor? What is a conductor? A conductor is any material that allows for the movement of charges inside it. Does let me see the material they're talking about. Insulated stands. A styrofoam, right?
No, sir.
Okay. Do you agree that plastics are insulators?
Yes, sir.
So insulators do not conduct. They are non-conductors. They don't conduct electricity. The same way they won't be able to conduct charges. So they are doing it so that to keep the system isolated. Keep the system isolated enough by not allowing charges to escape through the stand. Because remember, if your ground, because your ground is charged, remember your ground, i.e. your ground is charged. Remember, your ground is charged. That is why lightning always ends in the ground. So the lightning is formed by charges that are on the cloud that are, what can I say, flowing to the ground. So that's another type of, that's another example of electrostatic forces between charges. I forgot what the ground, the charge of the ground is. Let me check quickly. the charge of ground. Okay. Yeah, so the ground is normally negatively charged and the clouds are positively charged. So the potential difference between the negative and the positive charges causes a spark. Okay, so let's see what the last question says. The spheres are brought into contact and then separated as shown below. Let me see what the other questions are saying. Okay. The spheres are brought into contact and then separated. State the principle of conservation of charge. What is the conservation of charge?
Charges cannot be created or destroyed.
Cannot be created or destroyed, but can be transferred
From one object to another.
from one object to another. Okay. Which sphere loses electrons when the two spheres come into contact? Which one will lose electrons? Which one? Sphere A or sphere B, and why? Which one?
The reason I'm not sure, sir, but I think it's going to be sphere A.
Sphere A will lose electrons.
Oh no, it's sphere B, sir.
Yes. Why? I think you know the reason. Why? Because it has a lot of electrons. So if there's a lot of electrons, they will flow from a position where there's a lot to a position where there's less. It's called potential difference. Do you agree?
Yes, sir.
Electrons will move from B to A because B has excess amount of electrons. 4.5.2 from B to A. B has excess amount of electrons. Okay, Komisa, do protons move? Does protons move?
No, I don't think so, sir.
They don't move. The only thing that moves is electrons. Yes. So what happens when the electrons starts moving, and then what happens when they start moving? When you bring the two spheres together, what happens? Electrons flow to A until A and B have the same charge. This is very simple. For instance, the reason why people from neighboring countries are moving to South Africa is because South Africa is a bit richer than those countries. Why? Because we have access of resources and access of food. But wait until if South Africa and those neighboring countries have the same amount of food, it means no one will want to move to another country. What will be the reason?
Because they have access to resources.
Yes, if you have equal number of resources, it means there won't be any further movement of charges, right? So that's what happens after the flow of electrons from B to A. There will become a point whereby they will both have the same charge. From there, they are then separated. And that happens always, eh? It's a process that you must put in your mind. That's what happens when we're dealing with electrostatic forces. It's two charges that are brought together, and in the process, there's a flow of electrons until both spheres have the same charge. Then they are then separated. Now, let us calculate. They said calculate how many electrons transferred from one sphere to another when they come into contact. How do we go about this one? I know that you know how to calculate it. How do we go about this one?
So it's going to be Q nu is equals to Q1 plus Q2.
Which is going to be, our answer was, is this positive or negative? Negative, you agree? Because these are electrons. Yes, these are electrons. Okay, so we have -2 times 10 to the power of -9 plus the positive one is 4.4 nanocoulombs. So what is nano? That's times what? Nano is -9 and micro is -6. You agree?
Yes, sir.
Okay, so what is it that we're gonna get? I think we're gonna get 3.1. Am I right?
Let me check, sir.
Okay. Is it correct?
Yes, sir.
Okay. Now, but remember the question said calculate how many electrons. It didn't say calculate the amount of charge. Calculate how many electrons. So how do we calculate the number of electrons? Kumisa?
Is it going to be change of Q is equals to Q final minus Q initial?
Q final is given by Q. No, it's change in Q. Change in Q. Q final minus Q initial. You are right, which is going to be. No, wait. I think no. My answer is not correct. I can see because this is a minus. This is a minus 2. Okay?
Yes,
Because
sir.
I actually treated it as so this is going to be minus 2 plus 4.4 divided by 2. I actually got 1.2. You agree?
Yes, sir.
Yeah, 1.2. Okay, Q, which is it positive or negative? I got a
It is
positive.
positive.
Yeah. Okay, so which means after the contact, the two objects will be positively charged with a charge of 1.2 each. Okay, so Q final is 1.2 times 10 to the power of minus 9. And minus, we will subtract the Q of we'll subtract the Q of the negatively charged object, or the object which has excess amount of electrons, which was how much? It was 2. It was how much? It was 2. It was minus 2 times 10 to the power of
Minus 9.
minus 9. So this will be a plus. So it will be 1.2 times 10 to the power of minus 9 plus 2 times 10 to the power of minus 9. So this is going to be 3.2 times 10 to the power of minus 9.
Yes, sir.
However, they want us to calculate the number of electrons that were transferred. So how do we go about it? Because that's the amount of charge transferred. That's the amount of electrons charged transferred. So how do we calculate the number? You agree?
Yes, sir.
3.2 times 10 to the power of minus 9, all divided by 1.6 times 10 to the power of minus 19. So how much are we going to get? I think we're going to get 2 times 10 to the power of 10. But you can check it. Did you get the same?
Yes, sir.
Okay. Yeah, I think we had a very productive lesson, which whenever you get any question, please don't hesitate. Just share it with me if you want me to go through it in the next lesson.
Yes, sir.
Okay, so enjoy your evening. I'll see you on Thursday.
Same to you, sir. Bye.
All right. All right. And also, I